All right, room 50. We're moving right along, chapter 5. Today we're on the third lesson in chapter 5, chapter 5.3, and it's all about estimating quotients. Remind me again, what does quotients mean? What does quotients mean, Joseph?
The answer you get from the division problem.
Oh, so we're estimating the answers to division problems. So that tells you right off the bat we're doing division today. And are we going to find exact answers? No, we're estimating, okay? And of course, your learning goal for today is to be able to estimate decimal quotients. Okay, so that gives you a little bit more clues. Not only are we working with division and estimation today, we're working with decimals. Okay, very good. Let's first take a look at the problem of the day. It says, Miss Thomas buys a new computer for $659. She plans to pay it off in 8 monthly payments. Okay, so a lot of times when we make a big purchase, if I don't have $659 right off the bat, some companies will let me pay a little bit at a time so that I can only pay a little bit of money each month. And at the end of 8 months, I will have paid off the entire computer. Does that make sense? She's going to pay the same amount each month for how many months? 8 months, okay? And says, what is a good estimate of her monthly payment? All right, so of course, step 1 is to find out what is the problem asking. What is the problem asking, Thomas? Okay, what is a good estimate? So we're trying to estimate about how much money is she going to pay each month if she's going to pay off her computer in 8 months, okay? What is the important information we need to solve this problem? Daniel?
She has to pay $659.
Okay.
And she has to pay off in the 8 monthly payments. And also the good estimates.
We are estimating. Is there any other important information we need in order to solve this problem? Rashika? Each month she's going to pay the same amount. Okay, very good. Then we have to figure out, do I need to do addition, subtraction, multiplication, or division in order to solve this problem? Siddharth?
First we need to we need to do division.
Okay.
Before that, we need to round 659.
All right. So let's think about our math facts. Okay. First of all, let's figure out what equation would we solve to find the exact answer. Tanvi?
659 divided by 8.
Yeah, 659 because that's the total amount, and I want to share it equally over 8 months. So that's a division problem. Now, that's what we would do to find the exact answer, but we don't want to find the exact answer because it says what is a good estimate. So let's think about our math facts. Is there any number that's pretty close to 659 that would be a compatible number with the divisor of 8? Yanming?
640.
640, because we know that 64 and 8 are compatible numbers. So what is 640 divided by 8, Adam?
80.
So Miss Thomas would have to pay about $80 each month if she's going to pay off her computer in 8 months. Okay? Is she going to have to pay a little more than $8 each month or a little less than $8 each month in order to make her payments? Nathan? Yeah, we know she's going to actually have to pay a little bit more than $80 each month because 640 is less than 659. Here's the scenario. Lots of you either went to Tahoe or Reno to go skiing over winter break, or some of us are going this weekend, or maybe over the Martin Luther King weekend, 3-day weekend we have coming up. I'm going, right? Okay, so Carmen also likes to go skiing. The ski resort where she goes to ski got 3.2 feet of snow during a 5-day period. So over 5 days, maybe Monday, Tuesday, Wednesday, Thursday, Friday, all together, it snowed 3.2 feet. That's quite a bit. It's like maybe this much. Okay? The average daily snowfall for a given number of days is the quotient of the total amount of snow and the number of days. It's asking you to estimate the average daily snowfall. Okay, so if I know all together over 5 days it snowed 3.2 feet, how do I find out the average of how much it snowed each day? What would I need to do? Well, it says the average is the quotient of the total amount of snow divided by the number of days. So what was the total amount of snow? Harshita?
3 and 2 tenths feet.
Yeah, 3 and 2/10 feet of snow, divided by the number of days. How many days did it take for it to snow 3.2 feet? Liam? 5. So the quotient, which of course is this answer, would tell you the average daily snowfall. Okay? Now, it's asking you to estimate, not to find the exact answer. So I want you to know that you can estimate decimal quotients by using compatible numbers, just like we did with whole numbers. Okay? When choosing compatible numbers, you have two choices. You can either only look at the whole number part of the dividend, or you can rename the decimal dividend as tenths or hundredths. Okay? Okay. Remember that the problem we're trying to solve is 3 and 2/10 divided by 5, but we're estimating it. So Carly and her friend Marco each find an estimate. Since the divisor, what number is the divisor? 5. Is larger than or is greater than the dividend, right? Would you agree that 5 is greater than the dividend?
Yes.
Okay. They both first rename 3.2 as tenths. 3 and 2/10 is how many tenths? 3 and 2/10 is how many tenths? Jason? Yes, 32 tenths. Now, Carly, she says, well, I know that 30 tenths is close to 32 tenths, and it divides easily by 5. Right? So I know that 30 tenths is pretty close to 32 tenths. Would you agree? So, and 30 divides evenly by 5, right? We know that from our math facts. It's a compatible number. So we can say, so she knows that 30 tenths divided by 5 is how many tenths? 6 tenths. Or what's another way to write 6 tenths? Yeah. Okay. So she said, I know that the average daily snowfall is about how many feet? 6/10 of a foot. Very good. Now her friend Marcos has a different way of thinking. He says, well, 35 tenths is also close to 32 tenths. Would you agree? And 35 tenths also divides nicely. It's also compatible with our divisor. So 35 tenths divided by 5 is how many tenths? 7 tenths. Or another way to write 7 tenths is 0.7. So the average daily snowfall is about 7 tenths of a foot. So Marcos' estimate was 7 tenths of a foot, and Carly's estimate was 6 tenths of a foot. Whose estimate will be closer to the exact quotient? And how do you know? Here's a new scenario. A group of students is going to visit a museum. Okay? The total cost for the tickets is $144.15. About how much money will each student need to pay for a ticket? Okay? The question here is asking about how much money will each student need to pay for one ticket? We of course need to know that there are 31 students going, and the total cost is $144.15. Okay, so in order to find the exact answer, we would need to do $144.15 divided by 31, right? But it's asking us to estimate. Now, let's take a look here. Let's compare our dividend to our divisor. Is our dividend bigger or smaller than our divisor this time? Bigger. So when our dividend is bigger than our divisor, what we can do is we can just look at the whole number part. What is the whole number part of our dividend? What is the whole number part of our dividend? Ariel? 144. So we can think in our head, the new equation we can think about is 144 divided by 31. But that's still pretty hard to do in our head. So let's see if we can estimate. Let's see if we can change the dividend and the divisor to make it easier. Okay? Is there a divisor that's pretty close to 31 that's easier to work with and easier to think about in our heads than the number 31? Harshita?
30.
Yeah, so it says use 30 for the divisor. Then find a number close to and greater than 144. So as you can see, 150 is pretty close to 144, right? And it's easily divisible. It's compatible with our divisor of $30. So what's $150 divided by 30? Misaki? Is what? 0.5? So what we can do is we can divide both numbers by 10 first. We can get rid of both of these zeros. So what's 15 divided by 3? 5. So each student will have to pay about $5. Now, my question to you is this going to be a high estimate or a low estimate? Is each student actually going to have to pay a little less than $5 or a little more than $5? Is 5 too big or too little? Divina?
They need to pay a little more because 150 is bigger than 144.
So if each student pays $5, right, then it all will have $150. Is that more or less than what we actually need?
More?
More. So actually, is this a high estimate or a low estimate? It's a high estimate. So if we pay $5 each, we'll have some extra money that we can go out and buy pizza with. Excellent. Now, what if we use a whole number less than the dividend? Okay, we're still going to use 30 for the divisor, but 120 is also pretty close to 144, and it also is compatible with the divisor of 30. So what's 120 divided by 30? Adam?
4.
4. So in this case, if we use a whole number less than the dividend, each student would have to pay about $4 for a ticket. Okay, so I want to draw your attention to what I put up here in the bubble. When you estimate using compatible numbers, you can use a number that is greater than or less than the actual dividend, right? Either one could be, as long as it's pretty close, it could work. Now in this case, which estimate is better? If we were going on this field trip with 31 students, sorry, 2 of you can't come because there's only 31 students, would it be better if I told you guys to each bring $5 or to each bring $4? Which one's smarter for me as the person organizing this field trip? Which estimate is better and why? Zara?
$5 because then everybody can go and you have like extra money.
Yeah, if you only brought $4 each, we'd only end up with $120. Would that be enough for us to go on the field trip? So in this case, the high estimate is better because it's better to have extra money than to not have enough money, right? Very good.